Question 1. What propagates faster, radio waves or visible light? Here is the electromagnetic spectrum, and as we can see, radio waves have a longer wavelength than visible light. But what does that tell us about their speeds of propagation? When we look at the equation for the speed of light, we see that the wavelength and frequency are inversely proportional, meaning as one goes up, the other goes down. So visible light has a higher frequency than radio waves. But hold on a second. A wave's frequency and a wave's propagation speed are not the same thing. What we need to do is look at this C term, which is the propagation speed of electromagnetic radiation, i.e. the speed of light. This is always the product of our wavelength times our frequency. And in empty space, also called a vacuum, this is always equal to 2.998 times 10 to the 8 meters per second. Thus, this is a trick question because all categories of light propagate at this speed. Question number 2. Convert 7.5 times 10 to the 13 hertz into nanometers. What type of wave is this? So we're going to use this equation that models light as a wave. C is equal to lambda times frequency. Since the problem is not explicit in what variables we are converting to and from, just the units associated with them, let's spell this out. We are given a number in hertz, which is the same as seconds inverse. That means that this number is our frequency. And we need to convert this into our number in nanometers. And nanometers it's the unit that belongs to wavelength. So in other words, we have to convert our frequency to our wavelength. Thus, we need to rearrange this equation to solve for wavelength. And what we could do is we could plug in all of our values and then rearrange and solve. But I highly recommend that you do it as just the terms and then you plug it in. Now we're going to replace frequency and propagation speed with what they're equal to. We're going to use unit conversion factor to go from hertz into seconds inverse because that's what relates it to the propagation speed. And we're going to convert meters into nanometers with another unit conversion, cross out all the units, and we're left with 4.0 times 10 to the 3 nanometers as our answer with the correct number of significant figures. So to fully answer the question, because we have to address what type of wave this is, the wavelength and frequency corresponds to infrared light range on the electromagnetic spectrum. What is the difference between electromagnetic radiation, light, and waves? I believe I explained this the best in this video right here at the top, either right here or right here, so give that a watch.